Right, so this is 3.3 scientific detection. The first question then is looking at a load of information about different types of water and explaining which sample you think is the hardest. Remembering from last year that hard water is caused by calcium ions, so F had the largest concentration of calcium ions, so that would be the hardest type of water. Then it moves on to say the weak acid, so they gave you the pH. A weak acid, well, looking first off with anything below 7 to be an acid, and then this is the closest to 7, so 6.4, so that would be the weak acid. State which compound is the least soluble in Taftswell Spring. So if you read the information, it says that Taftswell Spring is 20 degrees. So if you go to 20 degrees, the one that's least soluble is this one here, which if you follow the line up is B. Okay, state which compound is more soluble in groundwater in Wales than it is in Taftswell Springs. So the groundwater in Wales is 10 degrees warmer, so it's going to be 30. So you're looking for one that's, if you look at all of them, apart from, so actually what you're looking at is 10 degrees warmer than Taftswell Springs. So you're looking for the one that's got the highest solubility at 10, which is going to be this one, D. State which compound shows the largest change in solubility. This one has the steepest curve, again is D. A sample of 100 grams of water at 30 degrees is found to contain 20 grams of compound C. State whether it's saturated. Saturated means it can no longer dissolve. So if you look at compound C is this one here, and its solubility is actually 30 grams per 100 litres, so there's another 10 grams that could be added. Next question then is looking at flame test colours and silver nitrate tests to work out the names of the compounds. So apple green would give barium, cream would be bromide, lithium would be red, white precipitate would be chloride, sodium would be yellow, yellow precipitate would be iodine. Okay, same kind of thing happens here then. So compound A then, white precipitate forms with barium chloride, so that means it's a sulfate. Gives a green precipitate with NaOH, means it's iron. Okay, next one then, damp red litmus paper turns blue, so it's ammonia, and it fizzes with acid, so it's a carbonate. Barium then, flame test, apple green, and then it gives that silver nitrate and it gives a cream precipitate, so it's bromide. Lots of maths then on the next question. So the first one says calculate the relative formula mass, so that's just working out the MR. I've done the table, so you've got two sodiums, 1 carbon, 3 oxygens, times all together and added up, and that was 106. Okay, the relative mass of sodium hydrogen carbonate is 84. What is the mass of 1 mole? So you would do MR times by mole, so you've got 1 mole, so it would be 84 grams. Then it says how many moles are in 4,200 kg of sodium hydrogen carbonate. So you're then doing the mass divided by the MR, which is 84 in this case, which would give you 50 moles, okay? Same kind of thing then happening down here. This was 3 marks. First off, they gave you the mass, which was 0.0, okay? 0.013, and then I worked out the MR to be 170, divided by each other, and I gave you that, okay? Giving your answer then in standard form would be 1, 2, 3, 4. So it would be 6.1 times 10 to the minus 4 would give your answer then in standard form. Next question then, state which food colouring. That's a lie. First question's up here, chromatography. The student failed to produce a chromatogram using this method. State 2 errors in his method. The first one is he used pen instead of pencil, should be pencil. And then you should always start the water line just below the pencil line, not just above. Okay. State which food colouring contains is the most soluble, so the one that travelled the furthest, so that's going to be E110. State which drinks A, B, C or D is contaminated, so that was A, B, and C. Then it says give a letter of the horses that's not been given paracetamol, so nice easy question. Draw along, match up, so horse C has been given paracetamol. Looking then at the caffeine, which is there, none of the horses have been given caffeine because none of the dots match up. Graph then to plot. Okay, my line's a little bit dodgy from the iPad, but nice question to kind of plot your lines from this, 3 marks, and then draw a suitable line across. Okay, describe the absorption. As concentration increases, so does absorption. Use your line to predict what it would be at 0.3. So at 0.3, draw it across and then down. Okay, so if you notice, I've just missed. So it's a little bit before. If you look on, it's just a little bit before. So you could have put 0.059 if you wanted to. It's claimed that concentration is doubled as absorption doubles. Do you agree? This is true every time the concentration doubles, so it goes from 0.2 to 0.4 to 0.8. The absorption also doubles from 0.1 to 0.2 to 0.4. Name the pungent gas. That's going to be ammonia. Give the chemical name of the blue precipitate. Anything that's blue is going to have copper in it. It's copper hydroxide because you're adding hydroxide to a chloride. And then it's top swap drop of iron chloride. So iron is 2+, hydroxide is minus, top, swap, drop, top. And then drop. Okay, remember in the bracket because there's two elements. Give the name of the following substances. So we have got nitric acid plus something gives you a blue solution. It's going to be copper. The reason gas D makes me think it's copper carbonate. Okay, this one then is going to be copper nitrate. So it's copper oxide plus nitric acid. It's going to give you copper nitrate. Alkali E. So nitric acid plus something gives you sodium nitrate solution. Name the gases. So this is hydrogen because that's a metal on its own. So hydrogen, test for that, lit spin, squeaky pop. And then we discussed that this was carbon dioxide. So carbon dioxide, lime water turns cloudy. Nice, easy kind of question then to start you off at PA. I know it looks really hard, but it's not actually as hard as you think. Hydrochloric acid, which is HCl, reacts with sodium hydroxide. If you're not sure about sodium hydroxide, look it up. Okay, but they're evenly placed, so it's just NaOH because they've got exactly to do top, swap, drop. Okay, this forms sodium chloride. Again, if you weren't sure, look at the back. Okay, again, they're even and water only. Okay, that balances out, so that's all you'd need to do for 2 marks. Okay, it's not as hard as you think. Name apparatus X, that's a pipette. Explain the purpose of an indicator. It's the point of neutralisation. Final question then. Complete the table. So what you had to do was this number take away this number. Okay, this number take away this number. This number, take away this number, this number, take away this number. Okay, and then complete the table. You would add them all up and then divide by 4 to give you the mean.